Welcome to Lesson 71 in Saxon's Algebra 1, 3rd edition. Now this lesson is on trinomials with common factors and then subscripted variables. So two different things in this lesson. Now, factoring trinomials is something that we've done before. We're somewhat familiar with it. But the difference here is that there's going to be a common factor that we're going to have to take out before we can factor the rest. And so let's just look at that. You can see in each one of these expressions we have an x there, there, and there. So we can say that all three of these have a common expression of x. So if I take that out, what do I have left? Let's see. Now you notice I'm not doing two small parentheses. I'm doing a large parentheses. There's a reason for that. All right. What would I have to multiply this x by to get this term? Well, x times x squared is x cubed. And I'm going to do the same thing in each of these. I've got to multiply this by 6x and this third term only by 5. Now this looks more like what I'm used to doing, so I'm going to factor when I do my factoring of this expression. I'm going to leave this x out here. Now I'm going to do my two parentheses. I know that everything's positive, so I can go ahead and put that in. I know I have to have x times x, and then 5 only has two factors, 1 and 5, so I'll put those in. And then I'm finished with that. Alright, in this one, I can look and I can see there are two things in common. Each expression has an x, so I'm going to take that out. And each expression also has a multiple of 4. So I'm going to take 4 out. Now I'm going to factor what's left. This times what would give me this? Well, times b, sorry about that, made a mistake there. I also have to take that b out because the b is also in common. So let's try that, 4bx. Alright, so here in this first term I would only need to multiply by x squared to get x cubed. And here I would only need to multiply by x, or 1x. And here I'm going to have to say 4 times what is 80? Well, that would be 20. And then I'm finished, okay? Now, I'm finished with that step. I'm going to leave the 4bx on the outside. I'm going to go to my two parentheses, and I'm going to say, okay, x times x. The factors of 20, well, they're 1 and 20, 2 and 10, 4 and 5. Which one of those pairs is going to be able to be manipulated in such a way that I could end up with 1, because this is a 1 here? Well, obviously it's the 4 and 5. Alright, so now I have to ask myself, I need a negative when I multiply and a negative when I add. So one of these has to be negative and one has to be positive. If I'm going to end up with a negative 1 when I've added, the higher number is going to have to be the negative. So if I say plus 4 and minus 5, positive 4 times negative 5 does give me negative 20, and negative 5 plus 4 does give me negative 1. So you can always check your answers on these. Never a reason to be wrong on one of these. Now this is something a little different. Here we have the coefficient of the second degree term, and that means that it's something squared. If that is negative, we're going to have to factor out that negative so we can have a positive there, which means that it's going to change the sign for everything else. All right, now here I'm right back to the same thing I had in the other one. I'm going to leave this negative on the outside, and I can remember that to get this outcome, I needed a +4 and a -5. Okay, so that's how you do that. Now in this one, I have a negative, but I also have a common factor for all three of these numbers. So I'm going to take out -3, and then I'm going to, let's see, no, there's an x there, so I need to add an x here. So 3x is the common factor for all of this, -3x. And then I'm going to see what I have left. Well, here I would have to multiply by x squared, and then I would get this first term. -3x times what is -6x squared? Well, that would be -3 times what is 2? That would be 2x. And then how many times will -3 go into 72? It will go 24. So then I'm going to have -24. I'm going to factor that. Alright, so here I'm going to have x and x. And the factors of 24 that will give me a 2, I've got 1 and 24, 2 and 12, 6 and 4, and that's the magic number right there, magic pair. Alright, one of those needs to be negative, one positive in order to get this negative here. This needs to be positive, which tells me that the 6, the larger number, needs to be positive, and the 4 negative. Alright, now this says use elimination to solve. This is the subscripted variables thing that we're going to be working with, and they're going to use this later on in some word problems, and they're going to say the number of nickels and number of dimes or number of quarters. Most often that's what they're going to use. So we're going to think of it like that. We're going to use elimination to solve this problem. You know how to do that already. So let's say we're going to multiply this times -5, and then I would get -5 in n, negative, I'm going to change that plus to a minus right here. And then I'm going to change this 16 to a -80, because -5 times 16. Okay, so we'll go ahead and do our elimination. We've eliminated the 5s. Now we have 5 in D equals 45. Divide by 5. ND equals 9. And then we can put that back in and solve for NN. You know how to do that. That's the only difference with subscripted variables. Okay, so 5NN plus 10 times 9 is 90 equals 125. If I subtract 90, I get 5NN equals 35 divided by 5. NN is 7. Okay, in this problem, it's also subscripted variables, and we're going to think of it as number of nickels and number of quarters, but we're going to use substitution rather than elimination. Again, something you know how to do. And we're going to substitute in for number of quarters, number of nickels plus 2. All right, so let's go ahead and do that. 5n, 5 times the number of nickels, plus 25 times n plus 2 equals 290. Now let's distribute 5n plus 25n plus 50 equals 290. Let's add our like terms here. 25 plus 5 is 30 times the number of nickels plus 50, and then we're going to subtract 50 also, equals 290 minus 50. So now we have 30 times the number of nickels equals 240, and if I divide both sides by 30, I'm going to get the number of nickels as 8. So I've got 8 nickels. So if I have 8 times 5, which is 40, right here I'm substituting in 8, 40 plus 25 NQ equals 290. Sorry, I'm running out of room here. If I subtract 40 from both sides, I'm going to get 25 NQ equals 250. So if I divide both of those sides by 25, I'm going to get number of quarters equals 10. So number of nickels is 8, number of quarters is 10. Alright, let's work your practice problem. And let's factor. And first we're going to start by factoring out the common factor, which would be negative 4x. And then let's see what we would have left. We would have x squared for this first term, and then plus 7x, because negative 4x here times 7x gives us negative 28x squared, and then plus 48 divided by 4 is 12. Now I can factor what I have inside the parentheses, and let's see, I need the factors of 12 that will add to 7. I know that everything is positive, and the factors of 12 that will add to 7, that's easy, are 3 and 4. Alright, good job. Okay, now if you'll notice, B in your book says negative x squared plus 24 plus 2x, but that is not in factorable form. So we're going to switch it around where it is and have negative x squared plus 2x plus 24. Now remember, when we have this negative in front of the coefficient of the second term, or the term to the second power, we have to factor that out, which will change everything else inside, change the sign. So we'll have x squared minus 2x minus 24. And then we're going to factor that, leave that negative sign out there, and we're going to do 2 sets of parentheses, x times x. We know that we have a negative here and here, so we're going to have one negative and one positive. The greater one will have to be the negative to get a negative 2 there. Alright, so we list the factors of 24 that might, and then think about what could get us 2. We've got 1 and 24, that won't do it. 2 and 12, That won't do it. 4 and 6, and there we have it. Alright, and I said the larger one needs to be negative, so we'll have x plus 4, x minus 6. Alright. Alright. In this one, we are going to use, substitution to solve, and it tells me what to substitute in. So right here behind this 24, where it says in Q, I'm going to put in plus 5, because that's what Q equals 360. Then I'm going to do my distributing, 6 in plus 24 in plus 24 times 5 would be 120 equals 360. Combine these two like terms and I get 30 in plus 120, and I'll go ahead and subtract 120 equals 360, and I'll have to subtract 120 from that side also. And I get 30 in equals 240. When I divide both sides by 30, I'm going to get the number of nickels is 8. I will substitute that in beside this 6 right here. 6 times 8, which is the number of nickels, is 48 plus 24 in Q equals 360. And I'll subtract 48 from both sides. And I get 24 in Q equals 312. And I came over here and I divided 312 by 24. That was one I just couldn't do in my head. It's very easy once I did it in long division though. And I found that 24 will go exactly 13 times into 312. So that means my number of quarters is 13. So number of quarters is 13, number of nickels is 8. And finally, D tells us use elimination to solve. So I think the easiest thing would be to multiply everything here by negative 6. That would make this negative 6n, and that would change this positive to a negative 6nd equals, and 6 times 12 is 72, but it's going to be negative 72. And then I've eliminated my n's. 12 minus 6 is 6nd equals, let's see, 108. And if I divide both sides by 6, let's see, 1, 4. That means ND will equal 14. No, I'm sorry, it equals 18. So, very important that I get the right number there. Alright, and now that I know what ND is, I can substitute it in. My original equation up here said NN minus ND equals negative 72. That might be the easiest. So I'll have NN, no, it was plus 18 equals negative 70, or I'm sorry, equals 72. And then I'll subtract 18, and NN equals 54. Okay, sorry about that. I should have gotten my original here before I multiplied anything, was NN plus ND equals 12. So if that's the case, then I can say NN plus 12 equals 18. And if I subtract 12 from both sides, NN equals 6. All right, good job. I'll see you next time for lesson 72.